Okay, so I'm going to run through number 57 here. I've already drawn all the pictures on the board that relate to the problem. All the pertinent information is already on the board. I'm just going to go through the actual work itself. So what we have here is the ship, that's S. These are the three transmitter units, R, O, and Q. And we're looking for the place where the two Loran lines cross at S. So we need to find two hyperbolas, one of which has the focus O and focus R, and the other which has the focus O and focus Q. So I'm going to do the OR word first, and that would be the green hyperbola here. So the distance hyperbola with foci O and R. Now, in order to do this hyperbola, I need to find all the pertinent information. So the first thing I'm going to notice is that this hyperbola is vertical. So I'll be using a vertical hyperbola form. And what I'm going to do is I realize that the difference in the distances in a hyperbola is 2a. We talked about that in class last time. So in order to find the difference in the distances, I'm going to take the time between the signals, which is this 323.27 microseconds, and I'm going to convert it into a distance, which I'm going to use miles, because when you're doing distances like this, you in general want miles. So you're told that the radio waves travel at 980 feet per microsecond, which would get us to microseconds, and then I'm going to convert that into miles, because there's 5,280 feet in a mile. So that'll give me a distance, which I need a calculator to find. So give me just like half a second to grab one. So I'm going to take 323.7, or 27, and multiply it by 980, and then divide that by 5,280. And that gives me 60 point a bunch of zeros. So I'm going to round that to 60, and that's in 60 miles. So that 60 miles is the difference in the two distances between R and S, that's a distance, and between S and O. The difference between those two distances is 60 miles, and that difference is in a hyperbola 2a. So that means that A in this hyperbola really would be 30. Now, if you're looking at the picture and you're trying to figure out the other relevant information, well, the center is going to be halfway between the two foci, right? So we have a focus here at the origin, and we have a focus here at 0, 80. So that means that the center then is going to be at 0, 40. And that A is 30, we've got the center, we need B to finish out the regular equation here, right? Well, we don't have B, that's the conjugate radius, but we do have the focal length. Because the focal length would be the distance from the center to one of the foci, and that would be 40 in each direction. So using the relationship c squared equals a squared plus b squared, we can find what b squared is. C squared would be 1600. A squared would be 3600. Ha ha ha, I lied. A squared would be 30 squared, which is 900. Come on board. Problem with shooting these things live. You have to wait for the technology to actually catch up with you, especially since I'm doing the videoing and this board stuff at the same time. It's eating the computer's mind right now. So that would be 30 squared, which is 900. So that means that b squared is 700. So the equation of this hyperbola then is y minus 40 squared over a squared, which is 900, minus x minus 0 squared, which is x squared, over b squared, which is 700, equals 1. So this is the hyperbola with the green Loran line, and I'm going to take this hyperbola and basically get y by itself. That way I can use my calculator to graph it, because I'm going to be looking for the intersection points between these two hyperbolas. So I'm going to move the x squared over 700 to the other side. I'm going to multiply both sides by 900. That would be 9/7 x squared, 900 over 700. And then I'm going to take the square root of both sides, remembering the plus or minus, and then add 40. So the two branches of this hyperbola could be graphed on your calculator using this equation. And I could actually do the exact same thing now for the hyperbola that's pink. So that would be the hyperbola here. I would start by making it a horizontal hyperbola. I'd get the horizontal equation for a hyperbola. And then I would get the difference in the distances by getting that time that I was given, which in this case was 646.53. I convert that into a distance, and that distance is 2a. That allows me to know what a is. Then I can find the center, because it's halfway between the foci. And then I can find the focal length, because it's the distance from the center to the focus. Use the focal length equation to get b, and then write the equation of that hyperbola. Once you get those two hyperbolas, what you're basically going to do is graph each of them on your calculator. You're going to find the intersection point using your calculator. So let's say I have the intersection point here. Let's call it, I don't know, A and B. To finish the problem out, it was looking for the distance from O and the bearing from O. So just as a reminder, to find the distance, to move to that point, I have to move over A units and up B units. Oops. And that would be a right triangle. So you know, distance formula or Pythagorean theorem to get the distance from the station. And then to get bearing, I would find this angle in the triangle. But the bearing starts at 0 degrees of north and goes clockwise. So I would really need to find this angle theta and then actually find this for the bearing. I'm not going to do all that because it would make the video extremely long, but I think if you look in the book, this is actually this is number 57. If you look at the example in the book that they did, you can follow sort of the process. Hopefully this video helps you out. If you need me to do the second part, just let me know and I'll make a video for the second.